Jai Hind everyone. Today we are going to do applications of trigonometry, which is going to be the second part of the unit trigonometry. Now some applications of trigonometry forms a very interesting part of our daily lives. Before that, let us see this picture. It says the ladder needs to be 29.44 meter in order to save the cat. Now this picture actually gives us an insight of a very common everyday kind of a problem, wherein how to find out the length of given ladder or the length of the rope required to reach a point or something like that. You can see here that the cat is positioned on top of a tree, and there is a girl that who needs to put up the ladder, maybe in a slant, so as to save the cat from falling. Now here we're going to use the concept of trigonometry very well. Before that, let's quickly revise what is trigonometry. Trigonometry is a branch of mathematics that studies triangles and their relationships between their sides and the angles between these sides. Now what is the main word? The key term here is a right angle triangle and the angles which are associated with the right angle triangle, that is the two acute angles. Again, as a part of introduction, let us study the picture beneath the text. Trigonometry is a branch of mathematics that deals with triangles, particularly right triangles. We all know this. For one thing, trigonometry works with all angles and not just triangles. They are behind how sound and light move. That's interesting to note, right? And are also involved in our perceptions of beauty and other facets on how our mind works. So trigonometry, as you can find out, turns out to be the most fundamental to pretty much everything. Now look at this. Here in this picture, there are two people standing juxtaposed to each other at a distance of 50 meters. They are both eyeing towards an island. The angle at which this person is eyeing towards the island is 30, and the other person opposite to him is eyeing towards the island at 40 degrees. How do we find what is the perpendicular distance to the island? Now, if you look at this in a broader perspective, such a picture can lead us to think how we can use such a simple concept of right angles or angles corresponding to those right angles in everyday life. If I extend this small picture to a practical approach, I'll find that such a thing can be used by aviators. Such a thing can be used by people who work with the radars, with animators, with pretty much everything. And this is how we're going to study the applications. Before that, let's look at some of the key terms that we're going to discuss and we're going to use generously. Let's formulate the definition ourselves. Before that, let's quickly study. We observe generally that children usually, yes, look up to see an aeroplane high up in the sky when it passes overhead. This line joining their eye to the plane while looking up is called line of sight. Now that's very vague, right? Let's try to understand. Just imagine that I am looking at an aeroplane which is going to pass overhead. Now look at my eyes. My eyes are at this level which is perpendicular to my eyes, like this, my height, and this line, just an imaginary line. You'll have to imagine, children. Just imagine that I have a line and this line goes parallel to the ground. My eyes are at this level and the aeroplane is there, so I'll elevate or I'll lift my eyes like that. Same way, if I want to see an insect moving on the ground, an insect crawling on the ground, this is my level of the eyes and I have to, from here, I have to lower down my eyes to look at this level. But in both the cases, what remains fixed is the level of my eyes. And this is called the line of sight. S-I-G-H-T-F, as you can see the definition. Sight. Sight means, yes, the eyesight. Hence it's called the line of sight. The line that the eyes make at my particular level. Right? Now, after understanding this, let's see how do we use this line of sight. We observe generally that children usually look up. That means, let's try and understand that again. I have my line of sight, my eyes here, and there's an aeroplane, so this child will look up towards the aeroplane which is passing overhead. The line joining the eye to the plane while looking up is called the line of sight. Angle of elevation. Before this, let's look at the picture on the extreme right. Can you see that this person is trying to throw something towards this electric tower or this electric pole? Can you see the line of sight, that is AC? There is the level of eyes and the line of sight, that is the line joining my eyes to the object. This angle with which I have to elevate my eyes or I have to lift up my eyes is called the angle of elevation. Look at the definition. The angle which the line of sight makes with the horizontal line drawn away from their eyes is called the angle of elevation. Now in that, connecting it to the previous example, angle of elevation of the aeroplane from them. Look at this. I have a huge building and I want to look at the topmost level of the building, the height of the building. So can you see the building? We can consider that this building is going to be perpendicular to the ground, which is the perpendicular in the right angle triangle per se. The distance from the ground can be taken as the base, and the hypotenuse is nothing but the line of sight that my eyes are making with the height, with the topmost height of the building. The angle here is going to be the angle of elevation. Same way, have you ever given it a thought, how do we find height of Mount Everest? How do we find height of huge peaks? Right? So what do they do? It's all, see children, it's always easier for me to find the distance on the ground rather than of a tall building or a very high building. And if the object in contention is a mountain or a hill, it becomes extremely difficult, rather impossible for me to find the height of a Himalayan peak. So what shall I do? I'll start moving away from the mountain, right? I'll measure that distance which I have covered away from the mountain on the ground, and I'm going to coolly look at the top of the mountain. Can you see the mountain here? There's a person, just imagine that there's a person who is standing away from the mountain and looking at the top peak of the mountain. Here the angle is 35. Now this person moves 1500 meters away from 35 degree, where the angle was making 35 degree, and again now this person has an angle of elevation of 30 degree. Now one thing that is to be noted here is that the perpendicular, that is the height of the mountain, is going to be perpendicular to the ground, hence the name perpendicular and height. Now one thing to note here, children, is that as this person has been moving away from the previous point to the new point, further away from the mountain, the angle is decreasing. So let us quickly go back to the fact that as you move away from the object, the angle of elevation decreases. And as you move towards the object, the angle of elevation increases. You can actually see that many of us must have traveled to a hill station by road. As you start approaching the hill station, the hills start appearing to be bigger. That is, you have to strain your necks like this so that you're able to look at the top of the mountain. This is nothing but the decrease in the angle of elevation as you move towards the object, that is your hill station. Now this gives rise to one more term, which is the angle of depression. Now, if the pilot of the aeroplane looks downward at any object on the ground, then the angle between the line of sight and the horizontal line is going to be angle of depression. See children, it's nothing but just the opposite of angle of elevation. If I'm looking at something which is high up in the air, right, that makes angle of elevation, and if the person is watching me down, that will be angle of depression. Look at the picture. The topmost left side picture shows a bird quietly watching a mouse. Now the horizontal level of the eyes of the bird is given as the topmost line, horizontal line, and the angle at which the bird is watching the mouse, that is the angle at which the bird has to, lower down the eyes, that angle makes the angle of depression. And same way, the mouse has its line of sight towards the bird, and the angle at which the mouse has to elevate its eyes is the angle of elevation. Now this gives rise to the fact that Yes, you got it right. Angle of elevation will be equal to angle of depression because, yes, the two horizontal lines are going to be parallel and the line of sight makes the transversal. Same way, let's quickly read the given example. A boy standing on a tower observes a ball on the ground at an angle of depression of 30 degrees. The ball is located 60 meters away from the foot of the tower. Find the height of the tower. Now here we're not going to find the height of the tower right now. We're trying to locate where angle of elevation and depression would be and what would be the figure to draw in the paper or anywhere while studying. Let us say AB is the height of the tower, as you can see, and the boy is stationed at A. The horizontal line at which the boy's eyes are is AP, and the ball is stationed at this point C. So BC is the distance from the foot of the tower, which is 60 degrees. When the boy looks at the ball, down at the ball, lowers down his eyes at an angle of 30 degrees, which is angle PAC 30 degrees, and using the concept of parallel lines and alternate interior angles, your angle C also becomes 30 degrees. Now we need to find height of the tower. Here we can safely use tan 30, wherein tan theta is perpendicular upon base. The perpendicular here is AB, the base is 60. So tan 30 is going to be AB upon 60, and we'll solve.